Test, test, test. Test, test, test. Okay, finally can stream. Let me check out my sound. Okay, sounds fine, that's good. Okay, so today I'm gonna be talking about multi-streaming and we are gonna see how it goes. I haven't posted anything for like 8 months or something, I forgot. But yeah, it was because of the editing of the videos and stuff like that. I'm checking out my sound and I might be breaking, or I might be hitting a limit or something. Give me a second. Oh, I don't want to touch that. I'm just gonna move the mic a bit farther away. Hopefully it's not then too quiet. Maybe something like this. Okay, we're gonna try. Yeah, so I wanted to start streaming like a few hours ago today, but for some reason I don't even know. I guess a small round before we start. I don't even know, but the capture devices and the frame rate stuff was screwing my resolution. So basically I was getting a really bad resolution because my monitor is 144 Hz and the capture device I guess cannot handle it or something, so we get blurry stuff. So I had to limit my monitor to 60 Hz, which after using the 144 monitor it's pretty bad. It feels very laggy, but okay. Okay, I think then we can start. The OBS is not showing me the chat. Let's refresh. Nope, that's great. How can I see the chat then? Yeah, so basically what we're going to be talking about is multi-threading in blueprints. So that was the topic I was kind of interested in for some time, and I spent like last few weeks kind of meddling with it, I guess. So we're gonna go over that and how you can start using, I guess, more of your threads, even though you're in blueprints. How can I see my chat? Should I just go here, I guess? Okay, that should be fine. And the last thing to check is if you go to YouTube. Should we go here? Probably not. Yeah, I'm literally streaming for the first time like this, like just randomly. So I don't think I don't have like all the stuff set up and ready. So let me check again. I think I set it to public. Bam, bam. And yeah, I'm also trying to stream with 2 monitors. That's why I have a capture device. But for some reason in my country, there is like no high quality capture devices. I kind of managed to find like a cheap one, but anything like that's like $100 or something, it costs like extra $100 to just get shipped here, which is kind of annoying. So I didn't want to buy that and try like a cheaper one. And I guess I'm paying the price a little bit because yeah, I had to lock my hertz, my refresh rate of the monitor to 60 hertz. Yeah, I tried to solve it for like an hour, and there was like some random software trying stuff, but nothing worked, so fuck it. Hi, Ash. Yeah, so I guess we're gonna start. Usually these types of videos would probably be like, I don't even know, like half an hour if I edited it, but I can't be bothered. Editing usually takes, for like a half an hour video, I usually cut out like 20 minutes of content or something, like bad content, like me stuttering or something. So that takes me like probably 3 to 4 hours to edit, so that was really annoying. That's why I kind of, one of the reasons why I stopped streaming, but yeah, or stop posting videos. So yeah, let me then switch to my second monitor. Yeah, so let's talk about multi-threading. Yeah, so I'm gonna be using some random template I found, just like a simple kind of game template, just so we have some code that is running at runtime, just so we have something so we can kind of go over stuff and how typically an Unreal game looks when you're not using multi-threading, stuff like that. And also I'm gonna be using Unreal Insights to basically profile stuff. So let me actually also have so we need this. Yeah, it's gonna be a bit slow what I'm doing, but I just want to see if everything is running fine, because I'm doing it for the first time, so I don't know if the video is stuttering or if anything weird is happening. Well, actually latency is also small. Okay, that's good. Okay, latency is also small, so everything seems fine. Okay, if there is any issues, yeah, let me know. But okay. Yeah, so we're gonna be using some random framework. I've probably got this like free somewhere, or it's just free on Epic, I don't even know. But yeah, I just opened up something. So first thing that we're gonna do is just go through the basics. So what is multi-threading and why do we even want to kind of use it or deal with it? So first thing that I'm gonna do is just play the game. And what I'm gonna do is press this button, which is basically to start tracing, meaning start gathering information about all the things that are happening in the game. And if we can kind of walk around, look around, do stuff, we can stop tracing. I'm gonna close the game. And let's open it up just to see kind of what's happening. So I'm gonna start with the basics. So if you already kind of know basic stuff about CPUs, you can, I guess, I don't know, go get something to eat, get back in like 10 minutes when we are doing something, I guess, more advanced. But basically how your CPU works is you have cores, meaning like different processing units that all can individually do some work. And typically in game engines you would have like a main thread where everything syncs together, because those separate cores do not talk to each other, so they're kind of separately doing work. And there could be a lot of issues and weird stuff if you're just like doing stuff in parallel and you're not syncing. So the typical example would be if I, what was it, Alt F, I think, to draw. Yeah, this is also new software for drawing. I usually use something else, but it's lagging out in this PC, so I have to use this. So for example, what can happen if you're having like multiple cores and they're doing different stuff is, for example, you can have some work on core 1, and for example at this point maybe the core takes something from the memory and then maybe changes it and saves it in here. And at the same time some other core could start taking that same value here and maybe changing it and saving it in here. So what that means is that this guy still didn't manage to save his stuff, but the other core got the old value that also this guy got. So then this other guy is going to override whatever change this guy made. So stuff like that, so you have to kind of be careful, and usually game engines would have like one main thread and then a bunch of different threads. So today's CPUs have usually at least like 4 cores, usually like 8, 12 cores. So my CPU has like 12 physical and then 12 virtual cores, so 24 in total. And then we have threads, which is basically kind of processes that can be run on those cores. I cannot even go more deeper than that because I don't even know that. I can't go on too much into it, but hi, the USP master. Yeah, so I cannot even go kind of more in detail than that, but in general, that's kind of good enough to know. So if you look at this game, so this is what we just recorded by playing the game, and we have a little bit of gameplay. There is some stutters, I guess we could check out, but this might be just me pressing escape to start the trace, and then this is probably me just stopping trace. So game generally runs fine, but this is kind of an empty project, doesn't have much, so it would be kind of weird if we have stutters or like stuff like that. So we can pick any part of this, and in the Unreal Insights we can find, let's scroll a bit, we can find the game thread. So this is where all of your blueprint logic is running if you're not using multithreading. So what I'm going to do is check the engine loop tick. I'm going to right click, just select time range, and this basically just lets me kind of select this area. So this is like one frame in your game. And there is like few dedicated threads. For example, you have thread for GPUs, for rendering, RHI, so interface between like your graphics card and I think CPU or something like that. So there is like few dedicated threads, and then the rest are just empty for us to use usually. There is also, I think, animation thread, dedicated animation thread, and then dedicated audio thread, I think. But yeah, for now we're just gonna care about our game thread. So this is whenever you run anything in the blueprints, it's going to run in here, which means that this is gonna get clogged really easily, especially because blueprints have their own overhead, stuff is happening. So if you just look at this game, which doesn't have much, so we can kind of just check out what's happening. We have mass entity subsystem, so there is some stuff happening with this. We could zoom in a lot and then see what's happening. I'm not exactly sure what mass entity is doing here, but there's stuff happening. There is this wait for tasks, and usually you don't want to have this in the main thread, because basically that means their main thread is waiting for some other thread to finish its work and then plug it in here. But if you're CPU locked, then this can be pretty serious, because this can directly impact your frame rate basically. So we have some other stuff happening here. If you see like these big gaps, it might be that the Unreal Insights did not catch something, or that maybe there is some work being done in the background. Usually there's like ways to profile, but for this live stream I didn't want to go too much into Unreal Insights. We could do like a dedicated thing for this, but just kind of to give you a general idea of what's kind of happening here. Okay, so let's not go into too much detail here, but because this is kind of an empty project, we don't have much stuff in here, you can see there is a lot of wait for tasks, meaning like we're not even CPU limited, we're probably like GPU locked. There is also this big portion was for Slack, and this is for Unreal Editor. So after you package the game or run it standalone, you might see like a noticeable increase in your frame rate, because you don't have all of this overhead of the editor. You could even get like double frame rate or stuff like that, depending on how what your current frame rate is. But yeah, so this is kind of what's happening in one of your frames. Now, if you look down, I'm also gonna move this. So if we look down and we start going to foreground workers and background workers, you will see that it gets pretty empty. And if you never use multi-threading, usually you're gonna leave all of this empty. And all of these cores, so if you imagine like, let's say 60 FPS game, our game thread is gonna run at about 16.6 milliseconds per tick. And you can imagine now all of these background workers could also be doing work like 16.6 milliseconds of work without affecting your frame rate, and it's all empty. And this is actually good to see for the Witcher demo. I think they went into like more. They had like a separate stream where they went into more details about all of this stuff that they did, and you can see their setup. They basically filled all of this up. You had like around 90% filled up background threads. So they did ton of like parallel work on other threads, and that can save you a lot of kind of headache where just kind of filling stuff up in the game thread, you can get laggy really quick. So for example, this plugin does not do almost anything at all, but it's also empty, so you can't blame it. There is not much work to do. So we're gonna kind of try to fill that up and kind of see how we can use that. So let's kind of start doing it. This random actor is just, I just created a random actor just to set max FPS to something a bit higher. Since I'm using like a separate PC for streaming, we can just like max out FPS. It's not gonna affect the stream and stuff like that. So yeah. What I did when I was kind of trying to go more into multi-threading and see what I can do with like different plugins. Firstly, there is not many plugins for stuff like this on the marketplace. I found few of them. There is like probably 4 to 5 plugins that you can find on the marketplace. I think I found like one that I haven't bought because it was like over like $50 or something. So that's kind of too much for this like this specific feature, I think. But for the rest, I kind of tried, and I have few bought ones and then few free ones. And then at the end, I'm gonna go over like which one I find the best. So I'm gonna type async, and let's start with just one of these. Now I haven't enabled all of them because I don't want to have the clogged like blueprint list of stuff. So yeah, and also I kind of haven't. I don't have like anything scripted, so we're probably gonna get crashes. I might even intentionally crash just to show like you cannot do everything in background threads. There is like unsafe work, so you kind of have to be careful. But yeah, so let's first enable this one. So async blueprints extension. Let's restart. We can also close this. Unfortunately, we're gonna have to restart every time, but it's not a big deal. Should be pretty fast. Okay. I'm gonna create a blueprint. Let's create an actor. Sure, let's just name it like this. Okay, so I'm gonna right click and let's type async. So different plugins are gonna name stuff differently, but in general, if you type thread, async, multi-threading, whatever, usually you get a list of their things. So in here we have our threading, and this is the list of all of their things. So this first plugin, how it lets you run stuff on different threads, is using like separate objects that have like stuff localized on them. I guess I can, let's start with something simple. So create and run stateless task. Stateless usually means it doesn't bring anything back. So yeah, let me then kind of talk about the structure of different stuff here. Yeah, we don't also have a task. So this plugin works in a way where we create a separate object, and that object kind of has logic in it, and it does some work and then spits it out. Okay, Ash asked, I'm assuming you mean like, do you have resources still in Multithreading Unreal? Honestly, it's not that crazy. So the things I'm gonna cover here, it's probably like using like 1, 2, 3 nodes, and you kind of run stuff. But usually you can even like ask any ChatGPT type program, you can YouTube it. Usually it's not that crazy. You're basically running just some logic on some other thread. The biggest thing is just you have to be careful what you can and cannot run, and I'm gonna cover that in here. Kind of what you shouldn't try to run and what you should, because especially for stuff that okay, so blueprints are running nodes that somebody exposed in C++, and if that code in C++ was not made to be run on separate threads, there is even some nodes that check if you are in the main thread, and if you're not, they crash the program. So you just have to be careful what you're doing. Usually math operations, loops where you do some simple stuff usually works. So if you have a game where you do a bunch of stuff, you probably you're probably fine, basically. Or like you're doing a bunch of simple stuff, you're probably fine. So for this specific plugin, what we're going to do is create a new task. Okay, it's called async task. So there's some issues with this and we're going to cover it, but first let me just kind of show you how it looks like. So it's async task. Let's just do a short task. There's probably some meaningful like differences how each task runs, but I haven't gone through that. Let's name it simple async task. And what's happening in here is we have our execute. So this is some code that we run, and then we have our initialization. So this is going to be run once, and then this is, or actually this is I think when it gets created, and then this is when you actually run it. Right now what we are doing is basically creating it and running it, but you could do it separately where you create it and then do some stuff and then try to run it. So that kind of depends on you. And I'm also gonna do custom event, and what we're gonna do it is task. So this callback basically means this is going to run on one of the background threads, and then we're gonna call this function when it finishes, or this event when it finishes, on the main thread to kind of sync everything in and say to the main thread, hey, we finished the background work. And you can kind of do stuff in here if you want, basically. Let's compile, save. Okay, so let's make him do some work. Now this task is called generically execute, but I want in our Unreal Insights that we already tested, I want to kind of find my function. So I'm gonna do custom event. I'm gonna name it, what do we want to name it? Async test task. It's just gonna be a bit easier to find it, so I'm gonna name it like that. And let's do something a little bit heavy. Let's do a for loop, and let's just do some random calculation just so we have something that's happening. Let's do like 5,000 of the things. Let's do an integer. And let's just do something like this. Bam, and we can put this here. Okay, so let's compile, save. I'm gonna put this multithreading in here in the level. So when we play the level, multithreading will activate. We should trigger begin play. It should create a task. It should run the task. And on the callback, let's actually print something so we just know that it finished it basically. So we can print hello. Now this task is gonna be pretty fast, but yeah. So let's press play. Okay, we got hello, so we know that everything works. So now I'm gonna press start to start tracing. I'm gonna press play, stop the game, stop the trace, and we go in here. Now if I tried manually to find where the task is, you could kind of try to eyeball it like, okay, here was probably when I stopped playing the editor, so it was a little bit before here, but you can imagine going frame by frame, it will be really annoying. So what you can do is Control F or just right click here, quick find, add filter, then timer by name here, and we can do, how did we even name it? Async test task, yeah. So I'm gonna click this. So this basically makes it visible in here, or like grays out everything except that one. I'm gonna click this so it finds the last one. This is find the first one. This is like find next, find previous, stuff like that. Now it's really small. I'm just gonna zoom in so we can see it here. And we can close this, so now we know where it is basically. So now what you can see is that our logic is running in the background worker. Number doesn't matter, like wherever it is, it just found. There is some logic that finds where our task is being executed. And we can see it's short async task. We have our execute event, and then it's executing stuff. And then in here we can see so we can see all of our ads that we had. So we had like 5,000 ads in there. And it took about 2.2 milliseconds. We also should be having, so this is task end. We had print hello. So I'm guessing at some point later, because game thread probably is not gonna run, so it's not gonna run exactly when this task finishes our print. So I'm guessing it kind of ran it a bit later, so we can kind of try to see it. Maybe even run it at next frame or something like that. I don't think we can find it like this. It would probably be pretty hard. But yeah, we should actually named the callback, never mind. Task callback, so let's find that. Bam, so it's pretty easy to kind of find it here. Okay, so we were actually pretty close to find it. So we can kind of see what happened. Our huge task ran in the background and it just notified our main thread, hey, it was finished, and then we print stuff because that's what we decided to do when it finishes. And because of this, you can see how this task ran in parallel with all of this. So there is a bunch of stuff that was already running in the game thread, and we didn't have to stop the game thread, do the 2.2 milliseconds of work on the game thread, and then continue with other stuff. We just throw it back, do the calculations, go back in, basically. So pretty cool stuff, pretty cool stuff with using like background threads. Now, the biggest thing is you don't want to run anything there. So let me try to break it or crash it. What can we do? Like get player character, simple, move to actor. I don't know, we can do like this. I don't know if this is gonna work or not, but we can try. I guess it should just, yeah, let's see actually if it crashes or not. Let's try playing. Okay, did not crash. Not sure why. So there is different stuff, and this is like in C++. There is, I think we can do move to location. Something like that. Controller location we can leave. Does this have to be? This has to be an AI controller. Bam. We cannot get self, so we are gonna get player character here. Okay. Will this break? Nope, we still not make. Some nodes break, some does not. I did not actually test. I should have probably found a node that breaks, but basically you have to be careful because there is a bunch of stuff that if you run it in the background threads, it's just going to crash. And there is also another issue that you have to be careful. I'm not sure if I can set it up with this. I don't like. I'm actually not a big fan of this type of multithreading where we create a separate object, because when you create a separate object, you also have to pass in the variables. So for example, if I have, for our variable test int, we can do instance editable expose and spawn, and we should see it in here. Let's see. Nope. Create state, or maybe because I'm creating stateless. I'm gonna try this. Nope. less async task. Let's do this. Okay, now it exposes it. Okay. So if we are using this type where we have an object and then that object has properties, we would have to pass in so it gets copied on the other thread and then it changes, and then you have to paste it. You need to basically get it back in here and do stuff with it, which can be kind of annoying, but it's also a little bit more safe because you kind of have to deal with the changes that you make on another thread. So it's kind of safer, but some other plugins just let you run like an event and you can directly change. For example, if you had that test int in here, we could just directly change this value and you get some new issues with that basically. So for this specific plugin, you can already see kind of how easy it is to run it. So I just literally run this one thing, it creates a task, runs it on another thing, calls it back. That's about it. You can also create a task separately. And for this plugin, I'm just gonna go over one more thing. We don't have to do like thread pools or whatever. There is like certain sizes of things that you can have, but we don't have to worry about that. That's a whole other thing. So let's do create and run stateful task. I think for this one, I'm gonna have to create an event, create matching event. So for this one, actually, let's leave this. I'm gonna delete all of this. So for our stateful compared to stateless is that we have this task value here, which means when we finish, so if I compile, connect everything, we can even run the same code, just kind of show you an example. If we finish, let's actually do it like this. Task callback. And we need to cast to simple async. So we're basically having that, getting that simple async, and then we can do int, get our test int, connect it here. So because we have this task, so it is stateful, meaning it's going to change some state and you're going to get that state back and you can do stuff with that state. We should now get print the number that we get, which is index plus we did a calculation where we do whatever the value is plus whatever the index is. So we're going to get a huge number, probably like hundreds of thousands. But let's play even more. That's like 12 million or something. So this way you can do some calculations, you can get something back, and then on the main thread you can kind of sync it. So maybe you were calculating, you have a game with like 1,000 buildings, and then each building needs to do some calculation, and then you throw that in the background thread. So buildings are doing like some huge calculations which take maybe like 5 milliseconds, and if you did it in the main game thread, you'll be cutting your FPS by some percent. You could do it in the background thread and you get the information at the end. This could be like, instead of an int, this could be like a list of all of those buildings, and then it could be like, or like a list of all of their new values, and then you could do some loop and just update the values in the main thread or something like that, or you could even update it in the background thread. You just have to be careful for not multiple different threads touching the same value, because we're going to go over also that, how you can kind of make errors. But okay, hopefully this kind of makes sense how simple it is to start, and this is actually one of the more complicated multi-threading plugins. For others, you actually need to do less work. We had to create a separate object, we had to create it, we have the callback, we have to cast to. For others, you actually do less. So let's actually then go to another one. So I'm gonna close this. Let's delete. And let's go to plugins. Let's type async. The next one, so I'm not sure if this one is paid or free. I think it was like $5 or $10 or something. And there is some free ones in here, but yeah, we're gonna cover that. So let's enable a new one. Yes, so I think this one that I'm enabling is for 5.5, but I'm using 5.6. But you can still I just have like a dummy C++ class just so I can get source, so I can build sorry, so I can basically build the SLN file, meaning that I can get the plugin to work even though if it is for 5.5. So you can also do that if you want. There is also one really old for like 4.26 or something plugin that I'm not going to be showing because just too old, probably not worth using. But let's see how this one was called. Async blueprint tools. So let's type async. Hopefully we get that. And we found it right away. So this one you can see it's even more simple. It has like 4 or 5 things. And just because it's simple doesn't mean it's automatically better, because the other one had more options. It had like long tasks, short tasks, and there's probably good uses for them where if you want something to happen over multiple frames, you probably want the other one. And if you want something to just take like few hundred maybe microseconds or something, you probably want a short task, and there's probably some optimizations for that. But yeah, I didn't go too much into that. So let's see what you want. Let's do just simple run async task. So this one, usually if you have like stuff like this, like task body or like part where you run your task in the background and then you have on complete, this usually means a callback to the main thread. Similar thing like we did with the other one. The biggest difference here is just we just have it all in here. So if we do task body, connect it here. Sometimes it's not going to be compatible, and if it's not compatible, you can just create event, connect it to a thing, and in here you can just create matching, and it's going to give you all of the parameters. Usually it's not compatible if you have like parameters in here that are being passed. So you can just do stuff like this. But yeah, so we are going to do on complete. And it basically does the same thing like we did before. So we have for loop. We can do same thing 5000. I should have just copy pasted the other one, but oh well. Okay. It's not too big of a deal. And with this one, we can actually test another thing, another issue that you can have with running background tasks. Which is pretty important, but okay, we have one complete. Let's do print, and we should get the same value like we did with the other one, unless something went wrong. So let's check that. And let's do 5 seconds just so we can see it. Okay. So let's see, hopefully it doesn't crash. Yeah, we see the exact same number. Let's close, let's start our timing, play, close, stop. And when you do this a few times, it's like automatic. You can pretty quickly just get whatever you want. Quick find, so we are doing the same thing. So we quick find, add filter, start time, timer name. So this is your function name or whatever we are searching for. So we have task body here. It would be nice if you had like a quicker way. Maybe there is. I'm not like an expert in like Unreal Insights, but this is the way I found how to do it. So I'm sure there's like a better way to do this, but I'm just gonna zoom in at a random portion when I'm kind of close enough. It's just easier for me to search for it. And we can find that value. Now I noticed the other plugin we tried, I think it has a bit more overhead, meaning it usually takes tasks a little bit more to complete using that plugin, even though it kind of forces you to be a bit more safe because you create a separate object. But the other one took, I think, about 2.2 milliseconds, and this one took about 2 milliseconds, which could just be like a variability, like a random just chance to be like certain size. But when I was testing speeds, I was getting about 100 to 150 microseconds more on the other, which is kind of negligible if you're doing long tasks like 10 milliseconds versus like 10.1 millisecond times, like who cares, it's not that big of a deal. But if you're doing small tasks like 50 milliseconds and then the other one runs like 50 microseconds and then the other one is like 150 microseconds, that's kind of a big deal. It's like 3 times more expensive, but you're doing the same amount of work. And yeah, just if you're not familiar with, I guess, milliseconds, microseconds, I mean, it's pretty simple. It's just like 1 second has 1000 milliseconds, and then 1 millisecond has 1000 microseconds, and then so on. You have nanoseconds. Most times in the blueprints, even if you go in like a thing here, let's say whatever we're calculating, if I go in here, at most, at lowest, you're going to get about 100 nanoseconds. You can get like 0. That's because the accuracy of the insights, I think, goes to around like 100 nanoseconds. But usually you're going to get microseconds when you're running stuff in blueprints. So US means basically microseconds, and then NS is, nanoseconds. So like 2 milliseconds, not bad at all. And in the main thread, we should get the same thing print, but yeah, again, I'm not sure exactly where it is. I don't think we want to kind of spend time searching. Oh, I think I found it. But yeah, you get your print. So yeah, so if you're running stuff in blueprints, usually it's going to be like between like 1 to 5 or 10 microseconds, depending on what you're running. And that's also overhead. So there is like there is like so many things. So I'm probably going to do like separate videos on each, but also, for example, if you see like this little gap in here, this gap basically is kind of an overhead of blueprints where it kind of needs to initialize the task, and it takes a little bit of time. And usually it gets cut out when you package the project, and there is like nativization and some other optimizations for the blueprints. It's never going to be as good as C++, but it gets cut down. Maybe like this function right now takes like 12.7, and it gets cut to like 9 or 8 or 5. I think for like really simple functions that are really small, it gets cut by like 4 or 5x or something like that. But yeah, so hopefully it makes sense. And we kind of did the same thing as the other plugin, but as you can see, it's way more simple. So yeah, the downside is because it's more simple, you can screw up more easily, I guess. So let me then show you another thing, how you or what you need to be careful with multi-threading, because right now we're running just one task on a separate thread. But let's say you have like a dozen or 100 tasks, all small tasks running on another thread. So let's say we have 1000 loops, and what we do here is, instead of this, what I'm going to do is just add 1. So then we know that this whole loop is going to add 1000. It's going to be like 1001. I think we want to start like this. So this should be like 1000. We're going to loop 1000 times. So this should go from 1 to... so this should go to 1000. But what we're also going to do, or at least try, I'm not sure if this plugin allows it, some just crash when I try to do this. So for loop. So what we're going to do is just spam tasks on the background threads. We're just going to say spawn a task, spawn a task, spawn a task. Do that many times. And let's say we want to do it 100 times. Also change this to 100. So 100 times 100 is 10,000. So our final value, if this works well, should be 1000. So let's see if this crashes or not. No. But as you can see, we got a value of 1144. So that's pretty random value for what we wanted to do. Like if I do event tick, so sorry, not event tick, what am I doing? So if I do this, but then we do this, meaning we're going to do for loop on begin play, but we're going to run it all on the main thread, and I'm just going to print after we finish. And let's do compile, save, and let's press play. Okay, we get 10,100, so I miscalculated a little bit, but that's the number that we want to get, so 10,100. But we got like 1,144. So let's kind of go now. Underline set is going to be really helpful here, because we're going to see the reason why we get that random number, or seemingly random number. So what I'm gonna do is start the trace again. Let's press play. So now number is different, and it's all gonna make sense soon. Okay, so we have the random numbers, we have tasks that are running, so we need task body. Let's try to find it. Now, because we're running a bunch of them, we're gonna find a bunch of them, but that's fine. Bam, bam, bam. Okay. So let's find the last one, wherever that is. So as you can see, we have way more stuff that is highlighted. So let's close this. So this is all tasks. So they're just like bunch of tasks. We said like, I think maybe we can even see it on the main thread. We just said run async task, run async task, run async task, just one after another. And you can see them like being, so this one is the first one that went right away after him. This one went, then this one went, then I guess this one, it feels like there's a bit of a gap, but yeah. And you can see like just as this one finished, there is another one playing. And why did we get some random numbers? So if we zoom in a bit in one of the sections, what's happening is this guy, can we actually find one that is actually overlapping? So okay, this is a good one. So this guy took a value somewhere in here, changed it inside of this function, and then set it as a new value. This other thread that does not talk to the first thread at all did the same thing. Took a thing, set it as a new value, or tried to set it as a new value. Now they cannot do it magically at the same time. One of them went first, one of them went after. They both got the old value, and then one overridden the other, basically. So you can get a bunch of these, like you can see how this happened so much that we got value like 1144 or something. And we should have gotten like 10,100. So you have to pay attention to stuff like this, and you have to be careful with if there is already background task running with your value, or with this specific value, you cannot like just run another task that is going to touch that value, because you risk of overriding it and doing dumb stuff like this. So there is ways to fix this, and we're going to find a plugin that does that. But for right now, if I type async here, this guy does not have that option to kind of make it safe for us to touch a value on multiple threads. I shouldn't say a value, touch a variable on multiple threads. It just has like these 5 simple things, which are nice to kind of start off, but then you have to be really careful of what you're doing. And you have like stuff like loops, maybe you want to like delays, just like loops that continuously do some work in the background, stuff like that. There is like multiple flavors of how you can run stuff in the background. But the basic idea is just like you put a task on the background thread, it does it, and usually you have a callback. You don't even have to have a callback. I think it kind of forces you to have it, but you can just do stuff like this and not do anything after. Okay, so we saw this blueprint, this plugin. So it probably runs a little bit better for smaller tasks, but it is a little bit less safe because this one creates a separate object, forces you to pass parameters, and those parameters are going to be local. If you remember, we created a separate object that is a task, and we had to create separate variables on that task. So that is kind of a nice way to kind of separate it, but then you don't have access in real time to some variables of an actor. You just have copies of them, and you have to sync them later, stuff like that. So there's some issues with that, but it's a bit safer. But this one is a bit faster, so kind of different stuff there. So should I'm just gonna delete this because we're gonna be using probably stuff like this on other plugins. So let's disable this guy, and let's do the third one, async node plugin. Let's restart. So hopefully it makes sense, and yeah, if you have any questions, let me know. I'm gonna try to answer, but yeah. So this is kind of what I did in my spare time, I guess. Just went through different plugins, just try them out, see when they crash, when they don't crash. Right now we're doing fine. I could like try to run, I don't know, 100,000 tasks and crash it or something, but I want to kind of show more like practical ways to crash stuff, because it's gonna be happening a lot, and you might not be sure why it's happening. A good way to actually see, Andre is kind of probably a bit overly restrictive, and it shows you what is thread safe and what is not thread safe. But in here, if I do So this is just a normal task, a normal function that you create in Unreal. If you make it thread safe, it already tells you like you cannot run print thread safely, but I'm pretty sure you can just run it and print it technically. I'm sure there is like some issue, but it doesn't let you, for example, in here reference another object and its parameters. It says it's not thread safe. So there is a bunch of stuff that technically is not thread safe, but if you are careful, technically it could be, if that makes sense. But so let's find, okay, so this one has a tag. So I'm just like typing in here stuff because usually people that made these plugins, they just put it into different groups, and usually it's going to be async thread or stuff like that. So we have create async task, we have execute on background thread and execute on game thread. So you might be wondering, why do you need execute on game thread if you can already just run stuff on the game thread by default when you do begin play tick or just custom event? The reason is that sometimes on the background thread you want to run something on the game thread. So in the background thread you can say, hey, can you right now run this on the game thread? Can you just like let the game thread know that I want this done or whatever? So that's kind of the reason. So let's see how this setup works. So we have the logic that we need in here. Logic would be our body. We're gonna connect it in here. Let's see. So we have this. So we have an option, execute on background thread this logic, or we want to execute it on the game thread. So we're going to do background thread. Right now we're not looping it, we're just going to do it once. And we do not have on complete, as you can see, we just have one thing. But we should be able to do something like this. Execute on game thread, and then we would have to do this. It's a little bit more work to get a callback like before, but we can do something like this. So we create a task, but this time we run it in the game thread, and we should have the exact same logic as before, where this thing finishes, we get a callback on the main thread, and stuff happens. Now it's just fun to see if, I don't think we need to like look again in the Unreal Insights to see like if it's even running or not. It should be running. So we're just gonna assume so we don't spend too much time. How long have I been streaming? 53 minutes, goddamn. Yeah, so I can like spend like hours just on multi-threading, but we don't have to do that. I'm gonna try to kind of speed it up because I think you're kind of getting the idea of what different plugins are doing. It's not that crazy. But yeah, let's see if this works or not, or it crashes. It does work. So we see the number 8,207. What that means is, oh, I think we froze crash. Nope, just froze. What that means is there are way less overlaps. Now that is kind of interesting. Why does this plugin overlap less than the other plugin? The answer could be that this plugin maybe auto solves some stuff or like tries to kind of figure out, but I don't think that's the case. It might just be that it kind of has a little delay before it runs the task again, or it needs time to create. And while it's creating the task, the previous task already finishes. So there is like a little overlap between them. So I guess that's my theory, but we don't have to like theorize, we can just test. Okay, so this is task body. So let's play. Oh, now it's 4,000, so there is high variability, so I'm not sure why that is. Let's see. Quick find, add filter, task body. Bam, bam, bam. It's annoying that this is not a bit bigger here. Okay, let's see what's happening. Okay. Why is this 139 milliseconds? Okay, this plugin is doing something weird, which I don't like here. So what I'm gonna do here a bit extra just to test is disable GPU tracks, so we get a bit less clutter because there's random stuff that we don't need here, like render threads, RHI, we don't care about that. We could do like disable audio, but who cares about that? So let's actually see what's happening here, because it seems like it's just stalling. Oh, it just waits for a task. Okay, this is bad. So what this is telling me is that the game thread is actually just waiting for the background tasks to finish and waiting for the results, which is not great. Where is it then executed? They're all waiting. They're probably just all waiting for like one guy or something. Or it's maybe executed later. What's this? It's just audio. Okay, I didn't look at the name. What's happening here? It's so weird. Oh, there's tasks here. Okay, background worker 3. So this is creating stuff to send to the... This should be for the foreground to notify the foreground. Not the foreground, sorry. The main thread. What? Yeah, I don't even know what's happening, but I don't like it. It seems like there is some stalls, some waits while stuff is being executed, and it's only being executed on this background worker for some reason. So whatever is happening here, I don't like it. I'm just gonna do one more test. I'm just gonna remove this. Maybe that's kind of doing some weird stuff. Let's create, play. Now we do not get a callback, unfortunately, but that's fine. But this is already kind of a red flag for the plugin. I don't think I would use it with stuff like this, even though it might be faster than doing it on the main thread. Just the fact that it has stalls and doing weird stuff. Okay, let's see. Okay, now it's better. Now it's what we saw before, so it may be just that the other thing is stalling it. So execute multi-threading. So this is creating the tasks. 8 milliseconds. Okay, I think the other one, when we were testing it, I think it was like 4 microseconds to create the tasks. So this is doubling just to create, and then another 8 microseconds to run it. So 16 microseconds. Yeah, I'm not a big fan of this plugin. It feels like it's doing stuff very inefficiently. Also, just 1 whole millisecond to just throw stuff on the background threads. I'm guessing other ones had like 200 microseconds, 100 microseconds. Yeah, so not a big fan of this one, but it's kind of doing fine here. Also, if you want a callback, we saw what happens. We get huge stalls, also pretty bad. So, yeah, not the biggest fan of this one. Also doing stuff like this, like every time you have to like do like these 2 nodes to start executing stuff. Yeah, I think we are kind of done with this one. Not the biggest one, not the best one, but I think we are done with the async ones. So I'm gonna disable this. So we went through 3 of these. I think from 3 of these, I think I like second one the most, just because I'm not the biggest fan of it, like creating separate objects, stuff like that. Sometimes I just want to like run something quickly in the background thread. I don't need this whole setup, but it's still kind of good, and maybe I don't know, maybe in bigger teams is good, I don't know. This can kind of be more unsafe, I guess. Now what we're gonna type is thread, and there is game thread check is just a check where we're running stuff, we don't care about that. And then we have BP multithreading, which is actually my preferred plugin to use. So yeah, let's go through this plugin. And this one is free, and by a guy that I found. It's not even on the marketplace. I found him on GitHub. And when I tested his plugin, this is kind of an updated version of the plugin, but when I tested it, it was the fastest one, plus it was kind of nicely set up. And yeah, and we can kind of go over that a bit later, but yeah, let's first test that. So I think we need to type thread, and we can see we have a bunch of different stuff in here. And we're also now going to cover mutexes and atomics. Those are 2 ways for you to kind of run stuff safely, and we're going to go through this example where you run stuff safely in the background without having this issue where we have values that are being overridden by another thread and stuff like that. So Oh yeah, there is also some other stuff in here. Yeah. So this is gonna probably take a bit. I'm gonna try to kind of explain it well. So let's do one simple one, which is run task on a background thread. So we can just take a task, we can just connect it, and as you can see, pretty simple. We just run the task. I don't think we even need to test this, but you get the idea. It's pretty straightforward. You just create and run task. You also have with callback. So same thing as we had before. You can just run task. You can run it with callback. We have run on the game thread if you ever want to do some stuff on the game thread. Good thing also about having it separate like this instead of having it like attached as a callback is that you could be having multiple calls to the game thread from the background thread without having to just do it like once at the end or something. You can just call, hey, maybe you call it to the game thread to let the game thread know that the task was aborted, or you can call multiple times to kind of update the game thread. So maybe you need to do 10 milliseconds of work, or no, let's say 100 milliseconds of work, but the game is running at 60 FPS, so that's 60 milliseconds. So you could have like a track from time to time to see if you are running tasks longer than, let's say, 10 milliseconds, and then you just call the game thread and update, hey, this is like the updated thing that I'm calculating. I'm still not done, but I just wanted to let you know like what's happening basically. You also have stuff like run parallel for. So before we were doing for loops, but you could just do something like this. So let's, oh, we cannot connect it. So we cannot connect it because we have the thing we were talking about. So let's actually go to, so there is parameters there that we need to go over. So let's do create event, let's do create matching event, and we have the index, and that's why we couldn't do it. So let's do how do you type parallel? It's something like that. Two nope, one. Okay, my bad. Parallel task. Let's connect directly in here just so we have that separating. Let's say we want to loop 100 times. Now we have what type of parallel thing it is. Now I'm not sure exactly what each does, but you can see the comments, so you can get the idea. For single threads, I'm guessing this is just going to do one background thread. Unbalance, thread has a cost of a little bit more synchronization. So you can kind of read what it's doing. Run the rendering thread, make sure the process thread is called when idle. I'm not sure, I'm guessing it also uses rendering thread, but rendering, make sure the process thread is called when idle. Yeah, I'm not sure actually, never mind. I better not speculate there, but I can't test it thoroughly, so I'm not sure there. But if you connect this, and we get that index, but we don't actually care about it, but let's connect it here. So just for clarity, I'm gonna put them side by side. So what we are doing is basically running parallel for. We're gonna do 100 loops and we're gonna just throw it back. Now if we try to do this, and at the end we want, let's do a simple delay. Just we know it's gonna be finished after 1 second, so after a delay I'm just gonna print it. I just want to see kind of what the result is, so I just connect it. It's gonna be a bit messy, but that's fine. Let's press play. And we get 1143. So when you run parallel for, you are running stuff at the same time, so you have to be careful what you're putting here. This assumes that it's kind of unrelated work, and then you just get an index, and then or in here you get an index and you do stuff. So you have to be careful what you're basically running there. You don't want to do stuff that is overlapping. So right now everyone is touching this test int, so you probably don't want to do that. So good for like heavy calculation where it automatically just runs it in the background, and you have like one simple node instead of you having to manage with a for loop and stuff like that. And we could look at how it looks, but it's going to be the same thing where you just spam the background threads with all of this. And I'm sure we can get like different types of performance and stuff like that by changing this. But yeah, kind of a simple one. So let's do thread. I think we can start covering a bit more complicated stuff like mutexes. So let's kind of go over that. So a mutex is basically like a developer-made group that you say, okay, this group can only touch these types of variables, and then we're going to enforce it and say that nobody else can touch it, basically, while this other task is touching it, if that makes sense. So if you're running like multiple background threads, and they're all trying to touch the same mutex group, so in here we can say group 1. This could be like, I don't know, character, stats or something, whatever. Let me see how I want to run this. We don't need delay, we don't need parallel task. I think we can do task body, but we're gonna do something like that, I think. And then we're gonna do this. Do we want bit callback, I think? Yeah, I'm just gonna try to set it up, and we might crash it, we'll see how it goes. But yeah, let's test it out. So maybe something like that. So ideally what should happen with mutexes is it's going to try to go in here. If somebody already locked it, it's not going to be able to go inside. But if nobody locked it, then it's going to go inside and do the calculation. And it's going to lock it himself, meaning that you're not going to be able, other threads are not going to be able to touch this. So yeah, let's see if it crashes. Okay, did not. Now we did get 9,000 something hundred. Oh, actually, I think it's still doing the calculations, so it was fighting with it. We are doing a lot of calculations with like 100s. I'm sure there's like some unforeseen things because I do not have like enough cores on my CPU. I guess I don't have like 128 cores or something. So there might be some weird stuff happening, but this should give you like a safe result. Also, am I running? Sorry. Should I be running it in here? I forgot exactly how to use it. I don't think we should run it in here. This might crash it. Let's see. Okay, we finally crashed it. Yeah, so basically you want to lock it. Actually, we can also lock it on a different way. Actually, before we do that, let me do this. So I'm gonna start tracing. Let's press play. Okay, yeah, so it's still doing calculation. I'm doing kind of too much, and I'm doing multi-frame stuff. So I'm guessing it kind of bugs out. I don't think it's made for like doing multi-frame stuff. So I would be careful with like really big stuff. But the general idea of mutexes we can kind of cover here. It was task body, I think. Okay. So before, if you remember, it took us about 2.2 or 2 milliseconds to calculate everything. But keep in mind we're just spamming all of the threads, meaning like around 20 threads were all doing stuff at the same time. With mutexes, only one thread can be touching or only one process can be touching that thing, so it has to wait for other stuff. So we're gonna see kind of how that looks like in code, basically. It's gonna be a lot of stalling because we're just spamming it, so you wouldn't use mutexes like this, but it should give you like a general idea of what's happening. So let's find the first one. Who's the first one here? There was the last one. Let's say this is the first one, I'm not sure. Let's find it. So you can see how, for example, this background worker tried to do the task. It tried to lock, but it realized it doesn't have access to it. And then it had to wait before it could do the calculation. So we can see, I guess if I zoom in enough, only at the end it did calculations because it spent a bunch of time waiting. So mutexes, if they actually are working, or like there is actually collision happening, it's going to extend the time for something to happen. So for example, for this one, it had to wait 120 milliseconds before it could do anything because other threads were taking the job from it, and this one had to wait before it could touch the variable. But then you get the accurate results basically. But you can see how some of them waited for like 4 seconds. So if you waited long enough, it would probably finish the calculation. But this is kind of what's happening in the background. It's kind of locking stuff and not letting, so each thread just has to wait for the thread before to finish. And we should also be able to kind of track. So for example, I think this one, if you just click, this is the end. So you can see this one finished the work, and then where was the one? Yeah, this one finished the work, and then this one just started working and finished its own work. So that means that just before, somewhere in here, some other thread was doing the work. We could probably find it if we kind of scroll, but let's see. There's somebody doing something before. Yeah, I'm not sure. I have to kind of figure it out, but yeah, so somebody was doing stuff before, then this one took over, did its own work, then the other took over, did its work. So yeah, there's like stuff like that happening. So mutexes basically lock you out of doing stuff until somebody else lets you. Now this is one way to use mutexes. Another way is, with this plugin at least, is I'm gonna do thread, is to get thread container subsystem. So this just gives you a bit more options about stuff and how it works. So if I pull from here, and then we can actually just scroll and find it. Mutex. So in here you have a bit more fine control. The other node, it's kind of a single node, so it's simple, but it auto locks and auto unlocks, which might be fine, but sometimes you want to manually do it. So this would be a way to do it manually, where you try to lock. So for example, what we could do is this task body could try to lock. We could do like a branch. We would name this group 1. We can do critical section. We could try to lock. If we fail, we could do something. So it gives us an option to basically say, if we fail, okay, we don't actually want to do anything, or if we fail, we're just gonna wait and try again or something. I think you have no, we need a thread. We could do like trigger event or wait for an event to trigger. So maybe we just wait for something to happen. Maybe the other thread is going to let us know when we are ready, stuff like that. But it gives you an option to do some stuff or do some other calculation and then try to lock again, stuff like that. But yeah, and if it manages to lock, it's going to go here and say, I successfully locked, let's do some stuff. And then you do stuff, and then you do unlock critical section. And this identifier basically tells you, because you can have multiple groups in different blueprints doing stuff. And this is subsystem, this is for your whole project, so you have to be careful. You don't want like 2 groups to be named the same, so yeah. But how you would use this is basically you say, I'm gonna do this work. After the work is finished, I'm gonna unlock this, and everything should be fine. It is kind of what this guy does. This is just more customizable. You can do more stuff with it. So it can get a bit more convenient there. Another thing that you can use is atomics, and I know a bit less about atomics, but the general idea is that you have like an individual variable that is thread safe, and then, so let me do, we could do like get remove. Oh yeah, we also have queues. Queues are also interesting. It took me a second to understand queues, but I think I get the general idea. So get atomic is maybe let's do test. We can do set atomic. We will do test. And basically this variable can be anything. For example, we can do this guy. And then we could do int here. Can we do like this? I just want to get it as an int. And then you do branch. And basically you say, hey, can I get this atomic? If this atomic is already gotten by somebody else, this would be false. If it's not, it's going to be true, and then you can basically get it and use it, and it's safe for you to use. I usually prefer mutexes because it kind of works with groups, and usually I don't find myself working with like just one thing, unless it's like a struct or something. But you can also do stuff like this, where you have atomic, you define it, you set it somewhere. Maybe when our calculation starts, for example in here, we set our identifier test to be this atomic. I'm not sure if I want to spend time like setting this up. But yeah, we set it in here. Then we, I would probably do like show exit pins here. Then in here, we do our get atomics and remove. Did we manage to do it? We would do stuff like this. Did we manage to get it? Okay, we did manage to get it. Let's set it. Let's do some stuff. And then when we finish, we can do some other stuff. Yeah, let me delete this. The setup would be a bit annoying. We, of course, won't use this then. But yeah, let's not go through the whole setup. But the general idea is similar kind of to mutexes, but it's more dealing with like individual variables and stuff like that. The third thing, and one of the last things that we are going to cover, is the queue. And if I understand correctly how the queue works, is basically, okay, let's remove atomics, is you put a variable in a queue. So this is, I think, just like a wrapper on the atomics. So you put a variable, let's call it, again, group 1, doesn't matter. Put it in a queue. Do we need this? We kind of went through that many times. We don't care about that. So you put a thing in a queue, then you can get it from a queue. But when you get it from a queue, it's removed, and it's removed in a thread safe manner. Because if you're like dealing with multiple threads and they're all taking something from, let's say, an array, what needs to happen in like the background of what you're actually doing is you take, I don't know, the last thing. That means that now the array needs to be changed, resized, stuff like that. And if you're taking it at the same time as somebody else is taking it or setting it, you get the same issue as before. But with queues here, you do not have those issues. So then what you can do is get the queue. So you can see kind of how it looks almost the same as or basically the same as the atomics. But we're gonna do get this thing, and just for fun, what we're gonna do, we're gonna print. Let's print. I'm just gonna do int again. I'm just doing this because, oh my god, okay. I'm just doing this so I can set the wildcard. But yeah, we can print this. Actually, let's do it like this. Sorry, I'm gonna change stuff. So I'm gonna print it, and I'm gonna print it again. Now this might look a bit weird, and hopefully it works. Maybe it doesn't work, but let's see. Let's press play. We get double false. Never mind, did not work. What do I need to do here? Maybe this value needs to be connected somewhere. The general idea is that we should get one true and then one false. And the reason for that is that when we get it from the queue, it should remove it from the queue, and then the other one should be false because this first printer removed it. But I think I need to connect this somewhere. Oh no, actually this is, oh my god, I think the issue is that this is maybe because it cached it. Nope. What would the issue be then? Yeah, I haven't created anything for this that I know is working. So this here, I think get also removes it. Maybe not. Oh, maybe because I'm not doing it in a thread safe manner. I think maybe if I was doing it in the thread safe manner, then it would work. Yeah, but in general, the idea is you can get it, it's removed from the queue, then somebody else tries to get it and they cannot because it's not in the queue anymore. But what can happen is if you have, let's remove this. If, for example, one thread gets it and then at some point in the time sets it back, then if the other thread tries actually to be like another thread here, and in somewhere in the future it tries to get it, it should get it again because the other guy set it. And the biggest thing for that is just to pay attention to the queue identifier. So this identifier is connected to the variable, so you need to just keep it connected there. And that's kind of the general idea how you would use it. Now, if you noticed with this plugin that we're talking about, we have way more stuff. We also have thread safety. We have ways to run code and be safe while it's running on multiple threads, touching the same part of the memory, and not just overriding stuff. It's going to cost a little bit more performance, but it's better that than to get some random value that is not your value, basically, or not the right number. You're like calculating something, you get like number that's not the answer at all. So this is my preferred plugin, and I also wanted to plug in the person who made this because I also so it's this guy, so Mr. Sunshine on YouTube. And this is his GitHub, and this is the latest version. Yeah, he created basically 3 days ago. So basically I was testing stuff, and there was an earlier version of his plugin, and I commented on his video that I did some tests. It was pretty performant, real nice. The only thing that I was kind of missing from his plugin was the mutexes, and that I will be using like his plugin plus another one that has mutexes, kind of as a combination, because I like how his plugin works, but didn't just have that one feature. And he was basically nice enough to comment back, say to make like an issue on his GitHub, and then in like 2 or 3 weeks he basically just updated his plugin, and it looks different. There is a bunch more stuff. So yeah, pretty cool guy. He did a bunch of stuff, and he's offering it for free. I even told him in the comments like, you should just put it in on like marketplace, do like $5-10. Easy money. I would just literally buy it over there, even though I already have it in here. But yeah, he said he kind of tried and didn't work for some reason. But yeah, yeah, pretty cool plugin. If you look again, bunch of different stuff we didn't cover. We basically covered maybe half. Oh yeah, few cool things that I bet some people would kind of like is enable actor multi-thread tick. So if you remember, your actors tick tick on the main thread, so everything is basically happening on the main thread by default. Get self. By the way, for the plugin you have to connect this in here. It's not going to give you error if you don't connect anything. It's just going to crash, so just to let you know there. So let's do something on the event tick. Let's do our calculations, our 100 things here. Let's just run it here. Bam, bam. And keep in mind, we're just throwing this tick on the main thread. And that doesn't mean that you can just get performance for free because you're throwing it on the main thread or on the background thread. Because again, you cannot run everything on the background thread. So you have to just be careful there. But yeah, you can even pick like tick group. So now it's pre-physics. So it's just going to be locked to that group. Or it's going to run at that point in time in your frame. So your frame is cut in different like sections where code runs. Sorry, give me a second. How to get a drink. Yeah, so there's different sections that can run different things. One caveat with this is that when it runs in the background thread, the main thread is going to wait if that is the only thing running. So if we do bam, so let's say this is our pre-physics tick, and it lasts like this because let's say this is like, I don't know, 100 microseconds. So there is some things happening in the pre-tick. Maybe, I don't know, engine is doing stuff, you are doing stuff. And let's say you have your other thread that is also running some code on the pre-physics tick, and it's a bit longer than what is happening on the main thread. So this is the main thread. We can say this is the background thread. What is going to happen is the main thread is going to be a little bit longer because it has to wait for your thing to finish, because the tick says I have to finish the pre-physics section. So whatever stuff is happening is going to prolong or stall the main thread to finish the task, because this tick is locked to that section of your frame. So just to kind of keep in mind, if you're doing like something really big, maybe you don't want to do it like this. You probably just want to do a background thing. Multi-threading means we will be able to have more AI actors moving. Not necessarily, because technically maybe you could try to move it, but I think you're gonna crash because there is like so let me say it like this. When you do like move actor to location, move actor to another actor or whatever, move character to another actor, you're basically calling function that calls bunch of other functions in the background in C++. So I guess we can still draw a little bit. So that function that moves the actor has like few things. So what it might do is basically first get the location to where you want to go, then it might try to move the character, then it tries to resolve collisions, so is it hitting something, stuff like that. Character move might trigger like a gravity check, it might have some other things that it's running because you have like character movement component. So when you just run that one simple function, it is actually doing like 5 things in the background. Now, not all 5 of these things, especially like collision and stuff like that, is not like thread safe. So what's probably gonna happen is you try to run your character, bunch of these things are gonna happen and it's gonna crash. Now, I tried in the beginning of the stream, I tried running it just on this, but there is various reasons why it's not gonna work for me, because I don't have all of the setup, so all of these things do not trigger. But if I had like a proper AI and I try to run it, I'm most likely gonna get a crash. So not necessarily you have to like do a little bit of custom stuff. One way to make your AI thread safe and work like this is to do most of work yourself and then throw it back and just move it on the main thread, or move the character on the main thread. So most things are kind of made for main game thread if you're just like running the blueprints. That's why you kind of have to be careful. But what you could do is create your own simple system. So essentially, kind of if we think about like what AI movement is we query the navigation volume. So if we have like let me draw it. I guess we can just quickly do a little thing here. If you have like a navigation volume and you have your character and you tell him go here, you can basically query the navigation volume and it's gonna find you like points. Okay, you got this point, this point, this point, you're here. Maybe there is like an object in here, so you have to go around it or something. Ideally, you might be like going like this, but the object is in the way. So you get these points. Then what you can do is move your character each frame a little bit towards the point. That's basically what AI does. And when you're moving the character, there might be some like collision checks or stuff like that, but you could just like move the character and let the engine deal with it. So the biggest thing that you would have to do is like figure out the path and then move the character yourself. So if you do stuff like this, you just have to be careful about collisions. You could do it manually and do it in a background thread, and then do minimal stuff on the main thread, and it should help you with performance, but you're gonna have to do some manual stuff yourself, basically. I wouldn't do set actor location because you are missing all of the stuff in between when you just do set actor location. Because like if I'm gonna draw another guy. Let's say this is like a capsule of your character. And there is an object here. If you just do move actor to location, that location might be overlapping with your character. You just like move him a little bit into the box. You just by moving the character, you just lost all of the intermediate stuff, which is checking the collision. If I move the character towards this box, maybe the character slides a little bit along the box, so it doesn't go through the box, it just slides. It might just stop completely hitting the box, and the character actually does not move at all, it just stays where it is. So you just want to set the actor on like a random location. You want to do extra stuff to ensure. So if you ever try to create like character movement from scratch, I don't know, just for fun, I try to do it with a mover. I should actually make a video about mover because I managed to make it work with blueprints, but I haven't. Yeah, I was too. Yeah, I got bored of it, but I had some other projects and I didn't want to spend like hours and hours making like competently made like character moving in mover, but I did make it like with like replication stuff like that, and it does work with blueprints with just a little bit C++. For some reason they did not expose like I think 1 or 2 functions that make the whole system work in blueprints. So I literally had like one wrapper in C++ with like 2 lines of code to just expose something, and it worked. But yeah, unrelated to this. But yeah, yeah, you could do it, but you cannot just by default move the character. For one of my projects, I just I'm using like what is it called? Air view avoidance, I think. And what is the actual name of it? I forgot what air view stands for. Velocity something, velocity obstacle. Basically, it kind of automatically tries to figure out where the flashbang here tries to find like the velocity where you're going to be moving in frames in the next frames, and then tries to kind of move the character a little bit, adjust him so you're not hitting other characters and stuff like that. And I actually disabled collisions for my characters and just used RVO avoidance, and that saved me a lot of computation time because you're not doing like some complicated like collision thing where just like characters are just kind of sliding each other's way, stuff like that. Yeah, so right now I don't have like any projects where I'm like moving the character in the background threads. I haven't bothered with that. Usually actually the navigation is pretty decent. The biggest issue, so I have right now a project where I run 200 characters 200 characters using navigation and using like character movement and moving it using like all of the characters like avoiding each other, stuff like that. It's 200 of them, and I'm getting like 140 180 FPS, something like that, because what I did is use their animation sharing plugin. Animation sharing helps a lot because animation were taking a long time in the main thread, and without that animation sharing plugin I was getting like 50 60 70 80, I don't know, it was like 1/3 of frames. So just because you're running like a bunch of characters doesn't mean like navigation is the issue right away, so you just have to be careful. If you ever want to kind of know what's happening with your game, do the thing I talked before. Use Unreal Insights, check all of your frames, check what actually is happening at your frame where you have like 50 FPS, what is taking so long to calculate, and then fix that. So for my project, for example, it was just animations, and I didn't even have animation blueprint. I just have like one animation sequence, and because it was just like running on 200 characters, had to do stuff there. It was expensive, but yeah. But yeah, kind of to sum it up, we kind of got off track. The general thing with this is, yeah, we have enable actor multithread. We enable this. Let's then we run the body, and let's play just to see what happens. So I'm gonna go here, press play. Hopefully it doesn't crash. Doesn't. Now we should be able to just start our Unreal Insights. Stop it. Go here. Close this. Quick find. Let's do task body. Let's move this. Okay, so you can see how we are using now foreground worker, and we have our tick, and we are not doing anything on the game thread. So we can see where is it starting. So our game thread is starting here, our tick is starting around here, and then right away we are throwing stuff into our foreground worker, and we are executing stuff in here. So you can see as long as the tick starts, we just say, hey, do stuff in the background with our character, and we did not have to like plug this in. 50 microseconds, not a big deal, but I mean, if you have like 100 characters with 50 microseconds, sure, but yeah, we just kind of move this to the background thread, so it's kind of nice. But again, you're still ticking every frame. Do you really need to do that? You should, yeah, figure that out. But yeah, this plugin basically has a bunch of extra stuff that you can use. You also have like run a component, so you have an individual component you can run. I don't think you can run stuff like character movement component or stuff like that. It's usually going to be your own custom components. Again, because Unreal developers did not make it with multi-threading in mind, meaning you can just throw it in the background thread and hope magically it works. But yeah. Yeah, I actually wanted to create a video on Unreal Insights, but I wanted it to be separate. Like this video I'm making right now is already, where is it? Hour and a half long. So I hoped it would be like an hour or less, but yeah, I can, I guess, talk all day about random stuff. But yeah, I wanted to do like separate ones. So how you can read Unreal Insights, there is like how you can see your events you're triggering, why are some events different, and how you can optimize their caching, batching, different nodes, and stuff like that. So I'm probably gonna do that at some point. I mean, I could make it like a next video or something, because that's another thing I think I can spend like an hour just talking about. But yeah, I think this is about it. So again, plugging this guy Loborchuk Andri, great guy, did this plugin. If you want to download it, you can see these releases, latest. Go in here, bam, this. It's for 5.6, but you could use it in 5.7 if you just build from source, but build a project. Yeah, by far the best plugin. I mean, you saw how many things you have. You have safety, you can run in different ways. I didn't even cover like half of it. There is latent stuff. So if I run this thread latent, I can just run it directly in here. So we don't even need like this, where you have like a separate event. You can literally just run it in here. Yeah, so a bunch of great stuff. Other plugins, if you just go async, this one is okay. You don't have mutexes, you don't have atomics. It's a shame. This one is pretty simple, probably good for like just getting into it, but for like serious project, probably not. I think this one was the one that did the worst with run on game thread, run background thread, so probably not that one. Yeah, I think that's about it. Let me see. Yeah, I think Blueprint extension plugin. Yeah, that one is pretty good. Yeah, I covered it in the beginning of the stream, but my biggest thing with that one is just you have to create like a separate object, which might be fine, but I kind of I just like it directly in my blueprint. Yeah, I have it like right here. I have to deal with like a separate thing. But yeah, especially not only like looks much better, but especially if you just spend like half an hour playing around with queues, atomics, mutexes, and learn that, you're so much powerful than just like without that. You have to be really careful what you're doing, and you're probably gonna get random crashes, errors, random numbers. But just like learning that is going to help you a lot, basically. Yeah, no problem. So I think then that's about it for this video. I think I'm just gonna the whole idea of this live streaming is just so I don't have to edit, so hopefully I can just publish this video, and that's about it. But you're gonna see. But yeah, I think that's about it.